All right, guys, I'm going to go over the answers to the test review. All right, so your test is on Thursday. Everybody's going to get a different test. So we're randomizing questions, shuffling everything around. So make sure you know what you're doing and let me know if you need some help. All right, so number 1. Okay, we are only graphing one function here. All right, so first thing you need to remember is 3 is going to be your slope. Okay, so 3, so this is your slope. Oops. All right, so this is your slope, and then you have your y-intercept. Okay, so graph your y-intercept first. So you have 5. From there, you're going to do 3 over 1. So up 3, 1, 2, 3 over 1. Down 3 over 1. Down 3. 1, 2, 3 for 1. 1, 2, 3, 1. 1, 2, 3, 1. Okay. All right. Now you need to look at your inequality. Okay, so y is less than or equal to. So that less than or equal to tells me it's going to be a solid line. Okay. So let's go ahead and draw a solid line. I'm just going to do the best I can. Okay. Now it's y is less than. So less than is going to be shaded. Okay, so less than, we're shading on the bottom, okay, below. All right, and then you're done. Okay, number 2 is the same way. All right, so we have our slope and our y-intercept. So let's graph y-intercept first. My slope is 2 over 3, so I'm going to rise 2, run 3. Now, this is positive. So my graph should be going left to right positive, just like number 1. Okay, the 3 was positive, so it should be going up from left to right. Okay, and then let's go up to 1, 2, 3 more. 1, 2, 1, 2, 3. Now I'm doing the opposite to get the other side. So down 2, left 3. Down 2, left 3. All right, my inequality is y is greater than or equal to. So since it's equal to, it's going to be a solid line. And it says equal to, so I'm shading, or it's equal to, so it's solid. And it says greater than, so I'm shading above. Okay, so y is greater than, so I'm shading above. Okay, and then you're done. All right, now for numbers 3 and 4, you are graphing multiple. Okay, so you have 2 different equations or inequalities that you're graphing. Okay, so the first one I'm going to do in red. Okay, so I have my y-intercept at -5. My slope is positive, so I'm going to be going left to right up. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And then I'm going to go down 2, left 1, down 2, left 1. Okay. My inequality symbol is equal to, so I'm going to make sure it's a solid line. Okay. And it's y is greater than, so I'm going to make sure that my shading, I'm shading this way. Now don't shade just yet until wait till we finish, because we need to do the second one. So the second one I'm going to do in blue. Okay. All right, so x is less than or equal to 4. Now we do not have a slope here, so this has no slope. Okay, so that you're going to treat this like x is equal to 4. So x is equal to 4 is a vertical line. So I have 4 here, and it's going to be vertical. It is less than or equal to, so I'm going to draw a solid line there. Okay, now it is less than or equal to, so less than, remember, is shading to the left. Okay, so now we can do our shadings. So I have this one, my red one, everything up, blue one, everything left. Make sure I can see your feasible region, okay? So points that are going to be part of your feasible region will be anything in my yellow part. Oops. Anything in yellow. I'm just going to do a little extra, show my feasible region. Okay? Okay. All right, next one. Now, with the first equation, you are going to have to change this a little bit because it is not in the form of y equals mx plus b. So we have to change this. Okay, I'm going to subtract 4x. So I'm actually going to come over here to, I'm actually doing it in the middle. So 4x minus 2y is less than 6. Okay, so I am going to subtract 4x first. So negative 2y is less than negative 4x plus 6. So my 4 is positive. I made it negative to go to the other side. Negative 2y stays negative 2. Okay? All right, I'm going to divide by negative 2. Now, when I'm dividing by a negative 2, I'm going to have y left over. My sign switches because I divided by a negative number. If this was positive 2, my sign will not change. I only change my sign if I divide by a negative number, okay? Not positive. Okay? All right. Less than turns to greater than. Now, I have negative 4x divided by negative 2, okay? So this turns into 2x, and I also have 6 divided by negative 2, which turns into negative 3. Okay, so this right here is my new equation that stems from here. So that really turned into y is greater than 2x minus 3. So let's go ahead and graph that one now. So negative 3. So my slope is positive, so I'm going to go up to right 1, up to right 1, and then down to left 1. Okay, now it is not equal to, so it is going to be dashed. All right, so since it is greater than, I'm going to make sure my shading is also greater than, which I'm going to shade this way. I'm not going to shade just yet. Okay, I'm going to graph my other equation. I'm going to do that one in blue. Okay, this one's already in the form of y equals mx plus b, so I'm going to graph my positive 3. Now my slope is negative, so down to right 1, down to right 1, down to right 1. And then I'm going to go up to left 1. All right, y is greater than or equal to, so it's equal to. So we need to make sure we have a solid line. Now, my slope is negative. So my graph, my line needs to be negative. All right, y is greater than, so I'm going to make sure I'm shading greater than. So I'm shading up, okay? All right, so let's do our shadings. I have one here, and then I have one here. So my feasible region is my overlapping, and I'm going to do it in yellow again, which is right here. Okay? All right, let's go to the back. Word problems. Okay, so we're back to oak chairs. All right, so a small business has some oak chairs. The business, so it says it was cost $100 to make an oak chair and $150 to make a walnut. Let's see. Let's make sure this isn't running. I have all the words here. Make sure we're reading it all correctly. All right, so some of the words got cut off on the first one. Okay. It says a small business produces oak chairs and walnut chairs. The business can make at most 20 chairs per week. So it says the business can make, it says at most 20 chairs. Okay, it just got cut off by the graph. Materials cost $100 per oak chair and $100 per walnut chair. The business has a budget of $2,400 per week for materials. Okay. Each oak chair sells for $400 and each walnut sells for $500. What are the number of oak chairs and walnut chairs that the small business can produce to maximize their profit? Okay, so we're just missing a few numbers. Okay, first thing I'm going to do is I'm going to say that X equals, oak chair and Y is walnut. Okay, so my first sentence is the business can make at most 20 chairs. I did not specify which I said oak or walnut, so I'm just saying at most they can make 20. Okay, so I'm going to say a combination of X and Y, so a combination of oak and walnut has to be less than or equal to 20. So at most 20 means less than or equal to 20. All right, and then it says it costs $100 to make an oak chair and $100 to make a walnut chair. So costing is not profit. Costing is money out of your pocket, okay? Also, the business has a budget of $2,400. So $2,400 costing $100, costing $150, that's how much you're spending. So I have $100 per oak plus $150 per walnut. It has to be less than or equal to $2,400, so because you cannot go over your budget. Okay? All right, and then the last sentence says the oak chair sells. So keyword here, sells for $400, sells for $500. So I'm going to say my objective function is 400x plus 500y. So that's my objective function. Okay. All right, we have to change both of these. So this is y is less than or equal to negative x plus 20. And changing this one, should have 150y less than or equal to negative 100x plus 2,400. Divide by 150, y is less than or equal to, let's see, we can take out, so it's going to be negative x. So it's going to be negative 2/3 x. So 10 over 15, yeah, so 10 over 15, take out a 5, 2/3. And then 2,400 divided by 150, 16. So I'm going to use this function and this function. Now, I do not have 20 spaces on my graph, okay? So I'm going to have to scale my graph. So let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to make each one worth 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Same thing here. Whatever you do on the x, you have to do on the y. Or whatever you do on the y, you have to do on the x. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, so let's graph this first one. So 20 is up here. down one, right one. And then the bottom one here, 16, down 2, left 3, down 2, left 3, down 2, left 3. Okay. There's my first. There's my second. They're both less than. My feasible region should be here. Oops, make that highlighter. Okay. All right, now I need my vertices, okay? So my vertices, now I know 0, 0 is not going to give me a maximum profit. Okay, I know that for a fact. Because if I can't sell anything and make a maximum profit. So even though it is a vertice, you do not have to do it every single time, because you know that's not going to give you a amount of money. So you have 3 here. So you can say 20, 0. You can say 12, 8. And you can say 0, 16. Now I'm going to plug them into my objective function. So I should have 400 times 20 plus 500 times 0. 400 times 12 plus 500 times 8, 400 times 0 plus 500 times 16. So here we should get 8,000. Let's see, 400 times 12, 4,800, and then 500 times 8, so plus 4,800. So 8,800. And then this one is 8,000 again. So the one that gave you the most money is your 8,800. So this is your answer. So your sentence should read, I can make 12 oak chairs and 8 walnut to maximize my profit. Okay? All right, the next one, you run a bottling plant. Okay, you receive $20 per case of regular cola and $25 per case of vanilla. It takes 2 machine hours to make a case of regular cola and 5 hours to make a case of vanilla. There are a maximum of 20 machine hours. There is not enough carbonated water to make 13 cases of cola in total. Find the number of each type of cola that is produced to make the maximum amount. Okay, so first thing, you're going to say X equals regular and Y is equal to vanilla. All right, now I also have my first sentence says you receive $20 per case of vanilla, or sorry, regular, and 25 per vanilla. Okay, that is your objective function. So 20x plus 25y. Okay. All right. The next sentence says it takes 2 machine hours to make a case of regular, 5 machine hours to make a case of vanilla, and there's a maximum of 50 hours that you can do with machines. Okay, so all of my hours are going to be combined together in one inequality, because I say 2 for every regular, 5 for every vanilla, which is going to give you 50 total. Okay, so you should say 2x plus 5y is less than or equal to 50. Because it says a max of 50. I cannot go over 50. So 2x plus 5y has to be less than or equal to. All right, the next sentence. There is not enough carbonated water to make 13 cases of cola in total. So every time I say in total, that means add, okay? So I'm going to say, now I'm not saying there's not a specific price range or anything that goes with cases. I'm just saying in total, however many cases I have, okay? So I'm going to say x plus y is less than or equal to 13. So I'm saying a certain number of regular plus a certain amount of vanilla has to be less than or equal to 13. Okay? All right, find the number of each type. Okay, so I'm done. Now I have to change my sentence, or change my inequalities around. This one's easy. This one's going to be y is less than or equal to negative x plus 13. This one, I'm going to have to do a little bit. So let's go down here and do some work. So 5y has to be less than or equal to negative 2x plus 50. So I subtracted 2x. Divide by 5. So I should get y is less than or equal to negative 2/5 x. 50 divided by 5 is 10. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now this one, scaling wise, it's a little bit different because this one's 13, this one's 10. I'm just going to make maybe 3 extra spaces here. And say this one's 13. So let's say if I did 13, I went down 1, right 1. 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 So if you have to make a few extra, make sure you still write them in the same, or in the right coordinates, okay? And then, now I do this because it's so close. If it's anything more than 3 or 4 or 5, then I need you to scale, okay? And then this one, let's do 10. So down to 1, 2, 3, 4, 5. Down to 1, 2, 3, 4, 5. Okay, they are both less than. Okay, so my feasible region is going to be here. And then let's go ahead and pick out our vertices. All right, so since our graph isn't big enough, just use what you have, and you can label your vertices. So 0, 0, yes, is 1, but it's not going to give you a profit. So let's say 10, 3 is this one. This one is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So 5, 8. And this one is 0, 10. Now, if you look at these numbers here that for my vertices, when you add them together, you should not get over 13, and that stems from here. Okay, you should not get over 13. 13 is okay, but you cannot get over 13. All right, let's go back to our objective function. So 20 times 0 plus 25 times 3. So this gives you $75. 20 times 5 plus 25 times 8. So 25 is 200. 200 plus 100 is 300. And 20 times 0 plus 25 times 10 is 250. So my money that I want, I'd rather have $300. But this is my answer, because that answers the question. It says find the number of each type of cola, okay? This gives me the number of each type of cola. So I want to make 5 cases of regular and 8 vanilla cases. I don't have a lot of room, but you could expand it more to say I want to make 5 regular cases of Coke and 8 vanilla cases of Coke to maximize my profit. Okay?